And for this post, I'm reflecting on class 1, where we worked through prime factorization, divisibility rules, and the sieve of Eratosthenes. That's a mouthful. I'm going to walk through what I'm doing as I solve each problem and talk about the strategies that helped me. So first, I'm starting with prime factorization, which is basically breaking down a number into the prime numbers that multiply together to make it. So I'm starting with 100. So I know 100 is 10 times 10. And each 10 breaks down to 2 and 5. So I'm writing 100 equals 2 times 2 times 5 times 5, or in exponent form, we can write 100 2 to the power of 2 times 5 to the power of 2. What helped here was starting with something familiar and working inward instead of overthinking it. This one is bigger. So before jumping in, I'm going to check the divisibility rules. We're going to do 5,643. So first thing I'm going to do, I'm going to add the digits. 5 plus 6 plus 4 plus 3 equals 18. So since this is the little symbol for since, 18 is divisible by 3, and since 18 is divisible by 9, I know, therefore, this is a symbol of therefore, 5,643 is divisible by 3. So I will divide step by step, continuing with everything until everything that is left is prime. So I'm gonna factor it step by step. So we're gonna go 5,643 divided by 3 is 1881, and 1881 divided by 3 is 627, and 627 divided by 3 is 209, and then 209 is 11 and 19. So I can say 5,643 equals 3 times 3 times 3 times 11 times 19. Or I can write it 3 to the power of 3 times 11 times 19. Next, we're going to move into some divisibility questions. The first question we're going to ask is 72 divisible by 6. To check for divisibility by 6, it has to be divisible by both 2 and 3. 7 plus 2 equals 9. 9 is divisible by 3. Therefore, 72 is divisible by 3. So because it meets both conditions of being divisible by 2 and by 3, 72 is divisible by 6. So 72 felt really straightforward because we trust the rules instead of second guessing ourselves. But let's check a bigger number. Is 243 divisible by 9? So let's use the rule for 9. Let's add the digits. 2 plus 4 plus 3 equals 9. 9 is divisible by 9. Therefore, we know that 243 is divisible by 9. This is a good example of how mental math can replace long division. All right, so now I'm just going to work through the sieve of Eratosthenes. I'm going to work fast because I'm running out of space on my phone here. So I'm going to cross out 1 because it's not a prime. I'm going to circle 2, and I'm going to cross out all the multiples of 2, 3. We're going to cross out all the multiples of 3, 5 is already crossed off, 7, 11, and 13. At the end, the numbers left uncrossed are 2, 3, 5, 7, 11, and 13. And what I liked about this method, it's visual and it makes prime numbers feel less abstract. Overall, the biggest strategy that helped me was starting with patterns, divisibility rules, factor pairs, and visual methods instead of jumping straight into computation. The most challenging part was the larger prime factorization problem, just because it required patience and accuracy, but it also showed me that these methods really do work if you trust the process. My main takeaway from this class is that number theory is about structure and reasoning, not memorizing steps. These strategies are especially helpful when thinking about how to explain math clearly to students.